Hey, all right, that is enough bloops and bleeps. I am John Park, and you are here for John Park's workshop. Thank you so much for joining me. Hey, where'd my workshop go? Let's flip that over. Ooh, I got some camera stuff to take care of there. Hello. So minus 12 dB, that was, huh? How about this? Let's bring this up. I don't want to blast you, but hey, that's getting closer to zero, especially if I yell. That just hit zero, I think. Audio, it's my favorite, and yet it's my bane. So, all right. Hey, we've got all kinds of cool stuff going on today on John Park's workshop. I want to thank everyone for joining us. First thing I want to do, not get out of the way exactly, but first thing I want to do is make sure that we all know about today's coupon code. So for today and today only, you can get 10% off in the Adafruit store if you go there, put a whole bunch of great stuff in your cart that you want to get, and then type in this coupon code, COPPER. I'm not exactly aligned with the thing. COPPER, C-O-P-P-E-R. We are live. We are live on Twitch now, too. The bot just told me. That's good. And it looks like we're live on Facebook. So hello, everyone on Facebook. Come on over to Discord if you want to chat, or YouTube. I've got the Discord chat up here right now, and I've got the YouTube over there on my iPad, so I'll be able to check that when I get over there. And I'm going to grab some water. Hold on one second. That's all the way back here across the other side of the shop. What the heck? So it is a beautiful day here in Los Angeles in the mid-70s, I think. You can hear birds chirping, but we're going to stay right here in the workshop and build stuff. Ah, delicious, delicious water. So, I also wanted to, before we get going on to the main event, oh, I got a lot of windows in the way, let's take that coupon code off of there. Goodbye, coupon code. We'll revisit that if we need to, but the coupon code today is COPPER. And I want to go double check that my workshop cam is at full glorious resolution, which it wasn't. So, oh, there it goes. Oh, that was weird. That's not 1920 1080. This is. Boom. All right, I got one or two other cameras to fix. Sorry about that. There are 700 steps for getting every live show ready. Precisely 700, and I had just missed by a couple. There we go. So today in the workshop, we're going to be looking at copper, cardboard, and circuits, just as today's title says. And before I dive into that, I wanted to, sometimes I've been experimenting with new segments on the show, so I have had my thrift shop picks, or picks of the week, and last week I had my rotary dial lineman's hand set, which I hope you found super cool, and I'm going to integrate that in a future project, I think. This week, though, I don't have a new find, but I actually want to do kind of a little bit of a, not exactly a blast from the past, but a blast from the present to some degree. And that is kind of a product of the week to mention. I don't have a fancy graphic for this up, do I? No. But what I'm going to talk about is there was actually an article, or there's a few articles going around about how the Adafruit Feather is becoming somewhat of a standard for people. I mean, there's no official ratifying board, but I'm excited about this because I have loved the Feather boards even before I started working for Adafruit. I thought they were a really great form factor, and I use them in a ton of projects. In fact, the last 2 weeks, if you've seen this show, you've seen me take a Feather and add onto it a little proto board onto which I built a synthesizer and plugged in a trellis. And so this is an example of the Feather board being nice and small, but being able to fit proto boards as well as a slew, like 50-something or even more than that, different, we call them feather wings, but different little peripheral accessories that plug on top for running servos, for running motors, for showing NeoPixel displays, OLED displays, and so on and so forth. So you saw me take that, and one of the cool things about the form factor is that while it is small, it's not hard to expand parts of it out like I did in the bigger version of my synthesizer here, which you can see. Oh gosh, let's look inside. There's the Feather, can I get it in front of the camera? Sitting on top of a proto board, but I still have the Feather on headers so I can lift it up and out and change it if I wanted to swap in for, let's say, a Bluetooth Feather because I wanted to do some Bluetooth MIDI or something like that. So a good way to get into the Feather if you haven't really explored that ecosystem is the very first AdaBox we did. In fact, let me jump over to this browser window here. Ooh, where'd it go? That's weird. Did I minimize it? I think I did. Huh. Doesn't want to show up, eh? What has happened to it? So while I fix that, head on over to the Adafruit store and check out AdaBox 001, which you can still buy, even though the subscription time passed. That was a couple of years ago now. We put each AdaBox in the store with a couple of differences. You are going to save money if you subscribe, and sometimes there are exclusive pack-ins. Usually there are exclusive pack-ins. But yeah, I can't seem to wake up that screen right now. But if you check out, I'm double-checking myself that I'm talking about the right AdaBox here. I think it's AdaBox 01, which was the introduction to the Feather ecosystem. Yeah, welcome to the Feather ecosystem. And that one comes with a 32U4 based Feather that's the Ada logger, so it has an SD card slot in it and you can log data to it, which is really cool. And that's a pre-assembled, pre-soldered one, and it has stacking headers on it, so you can plug it into a breadboard and then plug other wings onto it. And it comes with a NeoPixel Feather wing, so you can light up LEDs with it, as well as a whole bunch of accessories for getting going: piezo buzzer, jumper wires, an analog temperature sensor, separate LED, full-size breadboard, a flex sensor. So there's a ton of stuff in there, and that's the AdaBox 001. So check that one out if you're interested in getting into the Feather ecosystem. So that's what I wanted to say. I'm always talking about Feathers because I think it's a great platform, but I wanted to make a little special mention today about AdaBox 01. So check that out. All right, no idea why that screen capture window died, so you're just getting to look at blackness there. But I'm going to try to resurrect it so I can talk about the inspiration for today's project that we're going to build. So let me pull up another. All right, you're going to lose audio from me for a second, probably, as I make a new screen capture, because we've determined that was one of the weird things that's been going on. And I'm going to do new screen capture from a window. Pick one. And yeah, ooh, weird. All right. Yeah, it just doesn't want that one to be a choice anymore. So here's another one. And my voice is back. Good. Okay. So is this window? Yes. So I'm going to pop open a new tab in there, and this will work. So if we look at Adafruit and go to the blog, scroll down a little bit, Nick Normal, our beloved own Nick Normal, posted about, what, 2 days ago? I think it was 2 days ago. This little bit from the blog of Bunny Huang. I think I've passed it, haven't I? I've passed it. And there it is, this blog post, from SMT to dip on a paper breakout. So this, I'm going to actually follow the link here. There's a nice little movie here. Bunny Huang shows how he's prototyping small chips instead of on a breadboard, instead on cardboard or paper using copper tape. And he has a lot of reasons why this is actually more similar to building your eventual PCB-based circuit than a breadboard is, particularly for certain types of applications. So if we head over here to Bunny's, let me blow this up for you a bit. Bunny's blog, really great article. He has been working with a collaborator who, now I'm forgetting her name, it's in here somewhere, on Chibitronics, which is a paper circuits product, and you can get that in the Adafruit store, and it comes with, there's simple copper tape and LED and switch type of projects that you can learn on, all the way up through a full microcontroller that runs in this system. But I thought this was really cool. This is a piece of mat board for matting a picture or painting in a frame with a little SMT chip that has been broken out to copper foil, including there's a dual layer, there's a ground plane running over this blue tape here to avoid shorting something, and then running the ground back to the other side. As well as this one he made to plug into breadboards, which is pretty cool, so he can then plug alligator clips into the chip and run things off of the breadboard. You don't always have to use the breadboard, you can go exclusively on the cardboard. And it even has some neat features like being able to mark up, write information on the cardboard, because it's cardboard, you can write on it. So here's an example of actually laying this little SMT chip onto just two pieces of copper tape that have had some grooves cut in them. Solder that, and then he doesn't show a picture here of it, but in the video he shows slicing up those into 6 separate traces. So it has a lot of similarities to creating a PCB as far as routing your traces around, which is pretty cool. So, really great article. I recommend checking it out, including a nice discussion in the comments about different types of cardboard and their pros and cons for different types of circuits that you're making. So, that said, I wanted to head over to the workbench and get into making some pretty simple, I have an idea for a project we're going to build today. I have an idea for this little project, and we're going to start off with building some little resistors on cards that we'll be able to read with a clip. So let's head over to the workbench. And I'm not going to forget my water. And, oh yeah, I was going to double check, is my audio still going? And it is! That's so good. I'm glad I didn't click on that web page and lose you for 4 minutes while I mouthed things that you couldn't hear. Okay, and let me double check that my camera switcher is working. I think I'm not clicked in this window. Uh-oh, it stopped working, didn't it? That's curious. It worked a moment ago, so what changed? Let's come back here. I'm going to replug that. I have no one to blame but myself when this camera switcher doesn't work, because I built the thing, which is good and bad. All right. Well, let's try that again. Yay! That's working. All right. And then, as is customary, I got to find our live stream video. Oh gosh, now I'm talking to myself from the past. There we go. And we'll pop up the chat to live chat. There we are. Hey, all right. So, roll call. Who we got? Hey, Noah and Pedro. I didn't know you guys were here. Thanks for coming by. John Schaffstahl, Professor Elements, As Your Skies. I can't read everyone's name because we got a ton of people here, but thank you, everyone, for hanging out over in the chat. So, let me switch to this down shooter here, or this overhead camera, and we'll get a look at the principles behind building these little resistor circuits that I have. So, here was my idea. I wanted to build a circuit playground-based interface that could be for teaching resistance values, or it could be any kind of puzzle or game where you want to have identifiable elements, little cards, that represent some kind of data. So in our case, I want to change the color of the LEDs on this Circuit Playground Express by having someone clip this little card into a reader of some kind. So a unique object identification. This is often done with RFID. So you'll see projects like the chessboard RFID reader that I did, which was an escape room puzzle. And depending on where you placed a couple of the chess pieces, you were able to unlock a lock and this drawer would open. And projects where you want to uniquely identify things, not just, hey, I have something there, which magnets are really good for, but this particular thing is there. Very often you'll do that with RFID or near field communication, NFC. However, those are somewhat involved and relatively expensive compared to a humble resistor, which is probably part of a penny if you buy them in bulk. So something that kind of alerted me to this at one point was the fact that Apple Computer, when they make iPhones and you want to pair an iPhone with different docking connectors, kind of in the earlier days of the iPhone, and maybe they still use this sort of scheme. I think they've gone a little more advanced than that. But inside of the port on different devices, I think it is, there were, in an iPod Shuffle versus an iPod Classic versus an iPhone 1, there was a different resistance value running across a couple of the pins inside of the device. And so when it plugged into the dock, the device on the other side of the dock knew if it was something that it could charge or that it could stream to just by noting the value of that resistor. So it was a unique identifier, and it can be fairly precise, so you can be granular, so you could have a lot of different devices. You're really almost never going to run out of choices. So that was sort of the inspiration for this. And so what I've done is I've taken a few, let me switch back to this camera. I've taken a few, want to use that one? Sure, let's use that one. I've taken a few of these resistors, and here, just again, kind of if you're thinking about a classroom setting or teaching this, I have a bunch of these blue-bodied resistors that are really hard to read the color bands on because the paint on top of blue just doesn't shine through like it does on the more traditional beige. So partly to just keep me from losing my mind figuring out which ones these are, I've labeled them, and you can see I've put a color next to it. So I've decided a 2.2K resistor is going to light up yellow versus a 4.7K resistor, which is going to light up purple, which actually looks a little blue on my monitor, but that one's purple. And here's this very, very low resistance value. The 6.8 ohm resistor is going to light up green. So I've made a little sort of chart for myself here. So I have resistors that I want to be able to identify. And then if we switch over to this camera here, we can start building some little cards, experimenting with copper tape and cardboard that will have our resistors on them. So let's start off with a nice source of cardboard, which I really recommend looking at Bunny's article to see his thoughts on it. He's experimented with this quite a bit, it seems. Matte board does sound great. I don't have any in an obvious place here, but I'm using an AdaBox style box. So there's these black boxes, and I don't remember what came in this one, but we also have, this is not AdaBox sized. This one is. That's the bigger AdaBox size. This little guy here is kind of cool. But anyway, these are this fairly thin, it's a corrugated cardboard, but it's a single ply of corrugation between two facing pieces. And so it's fairly thin, unlike the bigger kind of puffier two-ply you find in like an Amazon box. And it's a little easier to bend along one direction. It has a grain to it, which is the grain of the corrugation, than it is in the opposite direction. You can still do it, but it'll go diagonal on you if you don't put a guide in there or score it. So anyway, this is a pretty good material to work with, and I have a lot of it. So what I'm going to do is cut up a little piece here, and just test out soldering a resistor to it that maybe we'll then alligator clip to. So let's grab some, I've got some of this nice thick copper tape, this wide roll copper tape, and this is the other common one that you'll run across. So I'm just going to work with this thick stuff because it's cool. Also, there was a good tip in Bunny's blog post from the woman who runs Chibitronics, whose name I'm forgetting again, I'm very sorry about that, about putting some glue on the outer edges of these rolls because otherwise they unspool endlessly. So I just use a little glue stick and hit a few dots of it, and it seems to catch every time it hits one of those quarter turns, which is pretty cool. Good tip. So we're going to take some of this, and then you've got a few ways of working with this. Let me make this just the size of my cardboard. Come down a little closer even. Oh, that's it. I've hit the limit. And I'm going to peel the backing. This is an adhesive-backed copper tape that has conductivity in the adhesive. So you'll want to look for this kind of tape versus some that you'll find in craft stores, particularly. Lamore mentioned this last night on Ask an Engineer. You'll find some copper tape that's used for stained glass crafting that does not have a adhesive with conductivity to it. So you don't always need to use the adhesive to stick onto things, but if you wanted to, say, bridge this to a pad on your circuit playground, it's often with that adhesive that you'll do it. So I'm going to go ahead and trim this a little more neatly now that I've got copper end to end. And then we can turn this into a few different circuits or components that are separated out just by taking an X-Acto knife. And you know what? I think I'm going to move to this overhead camera because it's even closer upper. So let me just push my cutting board here. There you go. It's nice and close. And it looks like it's in focus too. So you can see here I've made a little channel, and I'm going to lift off the tape right here. I'm actually lifting off some of the black paint on the cardboard there. And then if I want to, I can keep a shared ground on the other side by just lifting off here. And here. Okay. And so now what I'll do, let me grab, I'll just grab a couple of resistors. So let's get a 10K first. And I'm going to write on here which one that is, just so that I don't forget. I think I had, so in my color coding, I had decided 10K was going to be white. So I have a little white paint marker, since regular white markers don't work well or even exist sometimes. So let's see if we can see it if we put it on this side. So we'll do 10. Okay, boy, I picked the fattest white marker I have. Let me put it on the other side. Okay, so that's the 10K side. And white is our clue here. And then we'll use, how about this little 6.8 ohm resistor, which I had green as my indicator for, up here. So I'll grab a green marker. I can fill that in a little bit so I see it from this side and do 6.8 ohm. Point. Make sure that point is visible. So now what we do is I'm going to grab, now you can do this just holding it, it works just fine. The other thing I found that works very well is I have some of these helping hands that have a little alligator clip on the end, and this works really well to pinch the component to the board for soldering. So I'm going to do something like that. Yeah, looks good. So now I'm just going to blob a solder blob on there, and you can kind of put it anywhere you like on here. This is a nice big area we're working with, and I'm not adding other components. So that's all you need, just a blob of solder that gets onto the tape nicely. and onto the component. I'm just going to hit it again. It's nice when you see the solder pool out a little bit out onto the tape. Means you got it on there good. And please remember to have good ventilation when you're doing this. I have pretty good ventilation in the shop here, but normally I'll turn on a fan when I'm doing this. But it's noisy, so I'm sparing the microphone and your ears. And same thing. So this copper acts as a pretty good heat sink too, so you can see it takes a little while to get it heated up enough. So there's one side, and let me go ahead and clip that. You can grab some alligator. You want to be careful you're not nicking the tape up too much, but there's a ton of conductive area there, so you're not likely to ruin anything. Okay, so there's our 10K side, and then we'll lay down our little friend, the 6.8 ohm resistor. And you know, it's a little bit like doing, if you've ever done dead bug soldering, where you just run component to component to component in the air. It's a little like that. You can get creative with how you place things. You can lay them straight down, you can poke them through that and solder it a little bit. So you've got a lot of options for how this stuff goes on. I think just for fun I'll make this one rise up a little higher. And let's see if I can zoom in a little bit more for you. There. How's that? Is that still in focus? I think I'm going to have to refocus. So it did it. Sometimes it focuses on the shiny thing and then stops focusing on the shiny thing. Something about shiny things confuses autofocus algorithms. Okay, so we have that side, and let's get this guy here. I've done this sort of a similar thing before using just copper-clad PCB and just grinding out channels for my traces, but honestly that's a little scary because of the fiberglass that you kick up, and this is cheaper and easier, so I'm excited about using this technique for projects. So here we go. Now I've got let me clip that one there. Now I've got my little board, and let's jump back over to this camera, and let's take a look on just on the multimeter to see that we've got everything right. So let's find a multimeter. Here's one. Hey, look. And the finches chirping in the background is a nice, yeah, if there's any question, it's spring. Spring has hit LA for sure. So there we go. Here we go to, so I'll just clip ground to ground, and then I can check this side here, and we get, oh, I grabbed the wrong resistor, didn't I? Because that's not 6.8 at all. Or I've done something terrible and we're not actually getting the resistance I expected. So I'll try cutting that trace and see. Let's see if this one shows up as 10K. Yeah, that one shows up as 10K just fine. So what did I do wrong with this guy? What's your deal, guy? Oh, there we go. Yeah, so I just didn't pinch that very well onto here. I think it was kind of loose. So yes, it's 6.9. It's showing up as 7.0 or 6.9. So that's great. So that works well. And there's 10K. Cool. So there's a lot of interesting things you could do with this. One is if you had a little board of these and wanted to just run jumper wires off of them, you'd have sort of a bigger, harder to lose board of resistors that you could plug into a breadboard or a project, or just with alligator clips if it's something on a circuit playground, kind of at the ready, which is pretty snazzy. In fact, a lot of what I'm doing here today is about experimentation and exploring, so let's just give that a try. One type of alligator clip I've got is these little alligator clips with header pins on them. So you could use a regular clip. All right, so if I just take an alligator clip like this, I can zoom out a little bit for you. this is ready to plug into projects, right? Grab another clip for the other side of it. Sorry, I have a confusing array of colors, but here we'll put a black one on the ground side there. And so now we have a little 6.8 that's ready to go, 6.8 ohm. Maybe grab a different color for your sanity. And that's going to be the 10K. So kind of a cool little helper to have. There was a project I was looking at from Mutable Instruments, which is a Eurorack synthesizer maker, and they have these little things called breadboard friends. I showed them on the show here. I had some PCBs made from Osh Park, but I love that idea of breadboard friend. So these could be sort of cardboard circuit friends that you could just have at the ready to try things out. And you know, the neat thing is that if you had some reason to run this circuit around the backside, you could just grab some copper tape like this, and just that adhesive that I mentioned, let me zoom back in a bit here, is enough, this adhesive that's conductive is enough to run this somewhere else. So we'll run it around to the backside, say, for whatever imaginary reason. Okay, so now I've got that on the backside, and maybe I'll put, well, I'll just run it like this. So if we grab our multimeter, and let me put a regular tip on it so it makes a little more sense, actually. So you might have different little tabs that you can touch to get different resistance values. So I might have ground kind of clipped in all the time here, and then I can go in and touch this and get my 6.9 ohm resistance. And then if you're really running a more advanced circuit on here, let's say we put a 555 timer and a little battery, and to make a little flashing light circuit, you could use Kapton tape as an insulator, or any other insulator really. But so this, sorry, it looks a lot like copper tape, but this is Kapton tape. So if I run Kapton tape, if I can find the start of it, which is not always a given. Wait, let's take a closer look before I ruin. Ah, I found it. Okay, so if we have, snip that, a need to run something across this, now another piece of copper tape could go across the middle of this without interfering with or shorting to that. So this is kind of sort of the start of the idea of just playing around with building these copper circuits. So now what I decided for this idea that I had for making some kind of a reader or clip thing is, if I can solder the contacts on either side of the cardboard so that one leg of my resistor is touching one face of the cardboard and one is on the other, now I have this nice sort of two-dimensional thing that could plug into a reader of some kind. And so sort of a little differently than, oh, you're looking at double vision of me, sorry. A little different from this notion of running this traces and splitting the two traces here by cutting it away. The idea here is let's do another 10K resistor. I'm going to take another piece of cardboard, and I'll build a little sort of two-sided circuit with that resistor. So let's go, yeah, why don't we do it in this little view? This is a nice view. So let me start off with a little piece of cardboard here. By the way, another inspiration, and this is, it's kind of a zeitgeist thing. This is in the air a little bit. The Nintendo Labo has a ton of, it's all about cardboard and building these great cardboard construction, functional devices, gameplay. They use the sensors and they use the Nintendo Switch. So that's been a really neat thing that's happening right now. my friend Todd just told me that the new issue of Hackspace magazine is all about paper construction, and you know, it's not a huge difference really when you talk about doing construction with paper versus cardboard. So there's something in the air about cardboard right now, which is pretty fun. So here's my idea for this, is that I just want to wrap my resistor sort of around like this, and then solder it, just tack it, maybe get it off to the side here, to large pieces of cardboard, copper tape rather, which I can then read by pinching, and I'll essentially be reading the two sides of this. I don't think I have a need to do anything more elaborate. You know, one idea I had was making something where the resistor is hidden kind of inside of a two-sided arrangement of cardboard, but I'm not gonna do that. I'm not gonna get to that right now. So let's take. Let me zoom out on this a little bit for you, and I'll refocus. Did it? Sort of did it. How's that look? That looks pretty good. Let me try it again. Autofocus likes human body parts, so putting your fingers in there helps a lot. That sounded weird the way I said that, sorry. Okay, so where'd the big roll of tape go? There it is. So what I'll do is cut off a nice chunk of this, and I'm just going to estimate the length that I have, or that I want. I'll make it come up a little shy there, and maybe I'll cut it a little narrow. Okay. And then I'm going to cut it in half. And we'll stick that to either side of this piece of cardboard. And now, you know, I'm making kind of a little token or a chip or a card to read here, but one of the exciting things about building with copper tape and cardboard for your circuits is that they can get big, they can get elaborate, they can get folds in them, three-dimensional shapes. You can run traces between layers. You can make multi-layered boards. And it is exciting the way it really mimics PCB manufacture in a lot of ways, just on a less expensive and less caustic than doing it chemically, and a bit faster in some ways than milling these things. Obviously, when you get to a certain level of refinement or number of components, you may abandon cardboard and copper tape, but for a simple project, you're definitely welcome to try to get pretty elaborate. Okay, so here we go. That's my concept of just running this around like so. And again, I'm going to pinch that in there with my little helping hand and not blind you with that reflection of the outdoors. There we go. That's pretty good. Is that in focus? It looks focus-ish. And so let me just tap that down there with a little bit of solder. Okay. And you know, it's pretty forgiving if you make mistakes. You can cut away pieces of tape or make, you know, introduce new traces, which is nice. Now, you don't have to solder when you're working with copper tape either. You can definitely get away with a lot of alligator clipping of components to copper tape to create big pads. I've made versions of my drum controller with those. Actually, Colin Cunningham just showed he has a drum controller that he really uses to input MIDI notes into his music software. He uses Logic, and so he built a little thing he showed recently where he's just got some copper tape on his desk running up to a, I think a feather maybe, or maybe it was a Circuit Playground, I forget now. Okay, so now let's check this. I'm gonna switch that camera over to that one and that one. Move some things out of the way here. So now, with this one, I don't want to, I won't be able to clip that with my multimeter clip because I've got the two sides would both be grabbed at the same time. So I'm going to put the regular probes on the multimeter here. But this is sort of the intention, because of the way I want to grab this, is going to be with a reader that has clips on it. So let's pull the multimeter into view here. And there we go, just about 10K, 9.88. And let's see, I had made one before trying this out, and unfortunately I made that one also a 10K, didn't I? All right, so we got to make one more to make our demo interesting. So we've got to make one with a different value, at least one more. So I'm going to do one of these 6.8s. And in the interest of time, I'm actually just going to clip the 10K that I had done off of here. Or, yeah, we could get fancy, actually. We could go ahead and let me switch cameras. I'll put my money where my mouth is when I said that you can easily correct mistakes on this. So I'm going to say, all right, this one here, this is this 10K. Let's write it on there, too. So there's this 10K. And now I'm going to turn this one into a 6.8 ohm. And so I will simply make a little incision in my copper and give it a little bit of a border just so I know that it's not reaching over and touching. And peel that off. We could leave this side, but I'll be a completist and detach that too. And that could be reattached later if you changed your mind and decided, you know what, no, I really did need two 10Ks of this. It does pay to have a good sharp blade on your X-Acto, which I don't. I've got a moderate to medium sharp / dull going on here. And tweezers are helpful too. Okay, so that is now no longer a 10K board, but let's put our little 6.8 ohm on there. Where did I put it? You guys saw me do. Oh, there it is. Yeah, it's 10K plus that copper resistance, but if you look, my readings, at least on my multimeter, are not really showing any additional difference from the copper. Ooh, so Yannick Murray says, a question and answer game for my kid using cardboard cards and a Raspberry Pi. That would be really cool. Oh, I love that. I'm going to try to just do this simple Circuit Playground Express with CircuitPython thing today, but you could also do make code and certainly GPIO pins on a Raspberry Pi reading these resistance values. You get these really cool stuff. If you look at how electronic card games or books, simple, inexpensive things like that work, there are similar concepts out there. Also museums sometimes, I think, use a concept similar to this. So I'm tacking down the 6.8, and how are we doing on time? Oh, good, we got 12 minutes, so we'll make something that will react to these on the Circuit Playground Express in just a moment. And you could also hide the innards of this, right? You don't have to have these resistors exposed. They could be sandwiched inside of something and then your copper tape running out. This could be a three-dimensional object. You could bury these inside of a sculpture or some clay, so long as you're running the contacts out. Okay, so this one should read 6.8. So I'm going to switch over this camera again. There you are. So if it does, I'm going to mark it as such. So yes, 6.97, 6.97 roughly. And I think that's probably the same as I would get from the resistor itself, not worrying about the tape. Yeah, 7, oops, 6.97. So I just don't think there's any real appreciable change from that copper tape on there, for what we're doing at least. Okay, so now we've got the 10K, and let me write on this one. I don't know if this, oh, this will stick to the cardboard though. You can write on the cardboard neatly. 6.8 0.8 ohm. Okay, so let's run over to the workbench for a second, or rather to my workstation, my computer. I'm going to show you the code that I wrote to read the resistance value. So my creatively named program here, this is, I'm running Moo. I've lost my water again, hold on. I'm running Moo, which is a very nice, simple code editor for CircuitPython. It has a nice way to connect directly to the board that you've got plugged in. I'll do that in a second, and it's straightforward. It just doesn't do a ton of stuff, but what it does well for CircuitPython. Including some syntax checking, which is nice. If you, oh look, it says I've imported time, but I didn't use it, so I can turn off check, get rid of import time, check it again. Okay, now it's just yelling at me about some, I've got white space there I shouldn't, and so on. I'm going to ignore that, but once you get closer to done with your code, or you're feeling like procrastinating from your code, you can go through and clean things up, and that'll at least give you some hints for some syntax. Oh darn, did you just not hear me for a little bit? I'll bet that's what happened. I'm waiting for the chat to tell me. Yes, no, yes, no. We'll see. Maybe you heard me. All I said was that I'm using Moo here, and I'm using it as a code editor for CircuitPython. It's pretty straightforward, doesn't do a lot, does what it does well. And so what I've got here is essentially I'm bringing in some libraries that allow me to read the analog inputs on the circuit playground. So here's the circuit playground. And what we're going to do is look at pin 2 here that I'm pointing to, pin 2, to see what the voltage is coming into that as an analog input read. And I'm also going to use some NeoPixels. So I've imported NeoPixels and board, which covers a bunch of functionality on the board itself. So what I've got going, besides setting up NeoPixels, is I'm setting this resistor pin as my pin A2. I've made a little procedure here to fill in all of the NeoPixels at once, given a color, RGB color argument. And then I have a little procedure here that is called get voltage, and it looks at the value coming into that pin, sort of the raw value, and then multiplies it by 3.3 and divides it by the range of that analog input read. So essentially it gives us voltage, so we can see how many volts are flowing in. And then this is not elegant here. I'm just kind of copying and pasting a bunch of times, but it should be kind of clear what's going on, which is I went through and hooked all these different resistors up and just read my analog voltage values using the REPL, which I'll show you in a second. It told me, okay, if you put on that 6.8 ohm resistor, what you get is, I think, 3.26 volts flowing through, so almost the full 3.3, and so on. So each of those resistors gave me a different value, so I took a range and said, if you see something in this range, then I know it's that resistor. If you see something in that range, it's that other resistor. And that's it. I change the colors depending on which one we see. And so let's just do a real demo, and then we can come back to the REPL. Let me set those cameras. So I'm going to go back over to the workbench. So that's the code. I've uploaded that to Circuit Playground Express. And now let's head over here. I'm going to zoom that camera out a bit so you can see it a little better. That's probably good. Let's clean this joint. All right. So here's what I built. So I have the Circuit Playground Express, and then this is just alligator clips and messiness, which eventually I'll turn into nice cardboard and probably write a little mini guide for this. So what I have is a known resistor, which is this 10K resistor. And that 10K resistor is connected to the A2 pin that I'm reading on one leg and ground. And so that's the path that this circuit normally wants to take until we introduce other resistors, which then run to the 3.3 and also to the A2. So it's a voltage divider. And if you look what I've done is I've taken 2 pieces of cardboard. Let's switch to this camera for a second. So I've taken 2 pieces of cardboard, put copper tape on them, and then foam taped them to this little clip. I don't know where you get these clips other than they always come with helium balloons. If you buy helium balloons, there's always these things connecting them to like a weight or to hook them to something. So we have a bunch of these from birthday parties. But anyway, these nice little clips here. And so what you can see I'm doing is I'm going from sort of the full resistance to no resistance as I just let the 2 copper tapes touch each other, which is actually going to be pretty much the same the way I have it set up when we do the 6.8 ohm, because it's virtually no resistance. But here, watch when I clip my 10K card in here, we get white. And I take it out, and it's back to sort of this duller red. So that's a way of knowing, you know, whatever you're doing. If it's teaching resistance stuff, that's very literal and on the nose, but that's cool. But this could be anything. It doesn't have to be a clip either. This could be something where you're setting statues down to solve a puzzle. It could be flashcards for question and answer. There's a lot of different ways you could use this basic notion of changing something like lights or sounds based on which resistance value is read. So now if I put that 6.8 ohm in there, that one's going to go green. And sorry, you can't see those colors too well, but so there's nothing in there is red. My 6.8 ohm is green. My 10K is white. And then I don't think we'll have time to make more cards, but I'll just show you because why not? And I set these up. Here is what happens when a 6.8 goes in there, and I'm just going to touch. You can see that I'm just going to touch the clip. So that's orange. Here is, and orange is never easy to get on these RGB LEDs, but I found one that I kind of like. Here's a pinky purple. Can I get that to stay? I want to shield this so you can see the color peeking through. Oh, that doesn't look pink at all. Yeah, on the screen it goes white, but that is pinky purple. And blue, let's see how blue does. That might read a little better. Yeah, there we go. Come on. There you go. There's blue. So that is my little card reader for Circuit Playground Express using cardboard circuits. This is all brand new to me. I have not built these little cardboard and copper circuits before, and I'm very excited about the idea. The very first thing I did was I just tried doing more kind of a through-hole thing just to keep it steady, but I poked this LED into some cardboard and then soldered it where it was passing through these very little tiny traces of copper tape, and just put some voltage, like 2.2 volts on it, and lit up the LED. But it's a really exciting idea to be able to prototype stuff like this that has a very different feel from a breadboard and some advantages over a breadboard. Depends on the type of circuit you're working with. But that is my little card reader. So I hope you enjoy that. And stay tuned, because we're going to be doing a whole lot more with cardboard construction techniques, cardboard circuits, things like that, as we lead up to AdaBox 008, which is going to have some influences of cardboard, some influences of robotics, and is going to be a very, very cool AdaBox. So I'm excited to start working on that. Just wrapped up 07, and now we're going to dive right into 08 to make a really good box for you guys. One thing also to that, oh, that's a nice idea. C. Grover says, perhaps use individual neopixels to mimic the resistor color code. That could be cool. Maybe you can pick resistors that don't have like brown in them, but you could do stuff that has like red, black, and show which resistor color bands you have. Very cool idea. I like that. One other thing I want to show you was just an experiment I did with making sort of a tank tread out of cardboard. So Here you can see, let me switch that to be a big view for you. This is another ADA box that I've diced up and turned it into a pretty nice, it has not broken, and I've been messing with it, doing this with it. So I'm thinking about putting sort of a frame and some wheels in there and something to drive it, or maybe a conveyor belt or something like that. And you can probably guess just looking at this what the technique was, which was essentially start off with a piece of cardboard like this. Ooh, this knife is not sharp at all. I'm actually going to sizz that to get this piece of starting material. I'll just take this, actually. And so you want to find the grain. Okay, so that's the direction of the grain there. And then if you take a ruler, you probably want to use markings for spacing to get this. But with this corrugated cardboard, it's really easy to just make little incisions in the top layer of the lamination. It's kind of like a plywood. There's, in this stuff, an outer layer, the inner wavy corrugation stuff, which is what gives it its grain, and then the bottom layer. So the bottom layer here you can see is uncut. The top ends up, if you get your cuts a little nicer than I did there, ends up bending fairly easily. So it's a nice way to create things like cylinders, but you can also create moving parts with this, sort of like living hinges. If you've ever looked at living hinge techniques used in plastic and things like a Tic-Tac lid, that's a living hinge. It's just a thinner scored piece of the plastic that opens, that's the same material as the harder plastic that's thicker. To laser cut stuff with wood where little grooves are cut out, and wood, traditional woodworking, people have made living hinges. So that's another idea that I've been playing around with for forming these shapes or making a moving part like these tank treads. So that, I think, is going to wrap it up. Let me head back over to the workstation, and I want to thank you for coming. I want to thank you for hanging out in the chat. Oh, you know what? We've got a minute, so let me just show you what I said I would, which is the REPL running on this Circuit Playground Express, because this is kind of a key piece of how I determined the values I was going to use. So let's grab our cardboard pieces. Okay, so I'm taking this, I'm going to pull the battery on it, and I'm going to plug it into USB. Dun, dun, dun. And now, if you look over in my Moo session, when I hit REPL, raise that up so you can see it a little better. So I don't think that expands in size, does it? Oh, it does. Okay, so I'll make that quite big. So this is the run, evaluate, print loop, and if I hit Control D, as it says, it'll start running. Oh, huh. Waiting for button presses. That's my camera switcher that it found instead of this thing. Let me unplug that and try again. I actually don't know inside of Moo if you have multiples plugged in how you specify. And, oh, it looks like it wants me to scale it up again. So let's try that again. Okay, so the correct Circuit Playground Express is now being read. And so you can see right now I've got nothing in there, so it's basically returning the full 3.3 volts. When I open it, it goes just about to 0. And now if I take my 10K, so my little 10K guy, and put him in there, that reads 1.66 or so volts in the voltage divider. And here's my 6.8 ohm one, which again is almost no resistance, so it just basically is letting the full 3.3 volts through. So that's how that's working. Here's one I had made kind of with that split technique at first, and I'm running one side around to the back, so I think I'll be able to pinch just these two legs, and you should see again this is a 10K. So that's that sort of two-sided fabrication, if you can call it that, technique. So that is really helpful using the REPL inside of Mu, or you can in any serial screen session that you want to read serial with. You can look at this kind of stuff in the REPL. But it's very, very helpful for figuring out what values you're working with and how to arrange the different resistors so that you can uniquely identify them. And it seems to be fairly tight tolerances. Where did I wrote down as I was going? I got, let's see, for a 220 ohm resistor, I was getting 3.23 volts versus a 470 ohm resistor, I was getting 3.15. So there's enough difference there, and they're you can see they're pretty consistent. They don't wiggle around all that much. And you can get more precise resistors too if you're really trying to do something fine-tuned with a high degree of accuracy. But you can see here, this is my little 6.8 ohm. It's pretty much lock solid. Let me put that 10K back in. That one seems to wiggle a little more. So 1.676566, a little hundredths variance there of a volt. So that wraps it up for John Park's workshop for this week. I want to mention again our coupon code is copper, and that, if I check my notes, should be it. I don't want to forget anything. I think that's it. So thank you again for stopping by. I'll be in the Discord chat for a little while hanging out, so if you have any questions, thoughts, comments, come on over. And thank you all again so much for stopping by for John Park's workshop. It's been a lot of fun having you here as I start experimenting with copper cardboard circuits. Thanks so much. Bye-bye.